Hey there and welcome. We are going to tackle a big one today, mathematical functions. Now, if that word alone makes you a little nervous, don't worry. Stick with me because we are about to make this whole thing way simpler than you think. Let's dive right in.
So let's just ask it straight up. What in the world is a function in math? For a lot of people, this is a huge stumbling block in algebra. But honestly, the main idea is actually super simple. And that's our goal today, to build that understanding right from the very beginning.
And really, here's the big secret, the main takeaway if you remember nothing else. It is not as complicated as it sounds. Seriously, if you strip away all the fancy notation and the scary-looking equations, a function is just a rule. That's it, a simple, specific rule. And that's the one idea we're going to keep coming back to.
Okay, so here's the game plan. First, we're going to really nail down this idea of a function being a rule. Then we'll get into the language, how to read and write them. After that, we'll actually solve one together, step by step. Then we'll see what it looks like as a picture on a graph. And finally, we'll peek at where this all leads. It's going to be a quick journey from, huh, to I got this.
All right, let's jump into part one. A function is a rule. And the absolute best way to think about this is to picture a machine, like a little factory machine. You put a number in one end, that's your input. The machine does something specific to it, that's the rule. And then a new number pops out the other end, that's your output.
So let's put a slightly more formal definition on that. A function is a rule that takes an input value, does something to it in a very specific way, and this is the important part, produces a single output value. That's the key. For every one thing you put in, you get exactly one thing out. No surprises, no maybe this or maybe that, one input, one output, every time.
And this process is always the same, which is what makes it so reliable. Step 1, you start with an input, usually a number. Step 2, you apply the rule. The function tells you exactly what to do with that number. And step 3, you get your output, a brand new number that's the result of that rule.
Okay, so we've got the basic idea down, right? Input, rule, output. Now let's learn how to speak the language, because functions have their own special notation, and we're going to decode it right now.
So for this whole explainer, we're going to stick with just one example rule to keep things simple. And it looks like this. Now, how do you even say that out loud? You'd say f of x equals 3x squared plus 1. That first part, f of x, sounds a little weird, but it's just the function's name. Think of f as its first name and x as a little note saying, hey, x is the input we're using.
And just so you know, that letter F is nothing special. It's just a name, like calling a function Fred. We could have just as easily called it g of x, or h of t if, say, our input was time. They're just labels, kind of like file folders, to help us keep all our different rules organized.
Now this next part, this is absolutely crucial. That whole f of x thing, it's really just a fancy way of saying y. From your y-axis on a graph? Yep, same thing. So you can think of the equation y equals f of x. They're interchangeable. F of x is just a little more descriptive, but they both mean the same thing, the final output value. And that brings us to two other big vocabulary words you're going to hear a lot, domain and range. Don't let them scare you. The domain is just the official name for all the possible inputs, all the x values you're allowed to plug into the function, and the range, well, that's just the set of all the possible outputs you can get, all the resulting y values. So, super simple. Domain is your inputs, range is your outputs. That's it.
Okay, enough theory. I think we get the idea. It's time to actually do something. Let's get our hands dirty and see our rule in action. We're going to take our function and solve a real problem.
So here's the question. Using our rule, f of x equals 3x squared plus 1, what is f of 2? See what they did there? They just replaced the x with a 2. That's the question's way of telling us, hey, your input is 2. Go figure out the output.
The first step is probably the easiest. It's just substitution. Everywhere you see an x in the original rule, you're going to swap it out and put in our input, the number 2. So our equation now looks like this. F of 2 equals 3 times, in parentheses, 2 squared plus 1.
Okay, now we just have to solve this. But be careful. The order of operations, you might know it as PEMDAS, is absolutely key here. This is where people mess up all the time. So first things first, we handle the exponent. 2 squared is 4. Next up, multiplication. 3 times that 4 is 12. And the last step, addition. 12 plus 1 gives us 13. And boom, there it is, 13. That's our answer, that's the output. So we can say with confidence that f of 2 equals 13. Think about our machine analogy. We dropped a 2 in, the machine did its thing, and a 13 popped out.
But what does f of 2 equals 13 actually mean? Like, what is it? Well, it's more than just a number. And in this next part, we're going to see how that answer actually connects to a picture. We're going to turn this abstract math into something we can actually see on a graph.
So let's just recap what we just figured out. When our input, our x value was 2, the output, our y value, turned out to be 13. And remember, that's because f of x is just another name for y. Now we can take that information, an input of 2 and an output of 13, and pair them up. We call this an ordered pair, and it looks like this. Parentheses, 2, comma, 13, close parentheses. And if that looks familiar, it should. That's just a coordinate point, exactly like you'd use to plot something on a map or a graph.
And that right there is the magic connection. That ordered pair, 2, 13, isn't just a random pair of numbers. It is a single specific dot on a graph. It's one location, over 2 on the x-axis and up 13 on the y-axis. It's one tiny piece of the picture of our entire function.
Now imagine if we did this for a bunch of other inputs. What if we plugged in 1 and 0 and -1? We get a whole bunch of other points, and if we plotted all of those points and connected the dots, a shape would start to form. For this particular function, it happens to be a perfect U-shaped curve called a parabola. Our one little point, 213, is just a single resident on that beautiful curve.
All right, we're in the home stretch. We've covered the what, the why, the how to solve, and the how to see it. So what's next? Where does this all lead? Let's take a quick look at what's just over the horizon in the world of functions.
Look, what we've done today is just the beginning, but it's the most important part. Having this solid foundation means you're ready for what comes next. You'll soon learn about things like the difference between a relation and a function, how to add or multiply two functions together, and even wilder stuff like composite functions and inverses. This stuff is a massive part of higher math, and you've just taken the first biggest step.
So let's end right where we started. A function is just a rule. That's all it is. And now you know how to follow the rule. So I'll leave you with this question. Using that same function, what would f of 3 be? What about f of 0? The cool thing is, you can figure that out now. The power is literally in your hands. You've just unlocked a tool to solve a whole world of new problems.